The purpose of these designs is to build a working model of the eye's behavior, kept as simple as possible and using electronics, not mechanical control systems. Very briefly, that is an ideal motor, and that is a motor with feedback. And there is the motor output, which normally with voltage spools up to a specific value and stays there. Here's the entire circuit. What you have is feedback with RC phase delay, which is right there. What you have is a step input, which is the commanded output by the accommodation system, and then the result, which is normally a motor output. The value of the motor output is fed back to, in this case, to a comparator circuit or an error detector. And what you have out of the error detector is a small signal, which is amplified by 50, and that becomes the error signal to drive the motor to its desired result. The desired result must match the input. In this case, I have a meter to show that relationship. So now I'll show the error signals on the meters, starting with the error signal, error times 50, and then the output. Here's the error signal. Now the error signal will be about off by 0.15 volts. There you might be able to see it. Okay. And here's the error signal multiplied by 50. Notice the sudden pulse going all the way to 7 volts, 15 volts. And the pulse in the opposite direction, same thing. Point is, control systems are very stable when you build them correctly. And lastly, the output. The output is at minus 6.5 volts or 6.5 diopters, going to plus 6.5 diopters. And of course, back to 6.5 diopters. Lastly is the error signal multiplied by 50. This shows two things. It goes into saturation because the times 50 and oscillates at about 5 hertz. So that's characteristic behavior of a control system. Now the next issue is control systems are linear mathematically, but when you build them, they often appear to be nonlinear, as that is. So building an electronic model of it is a great help in deciding how things work in a nonlinear mode. So back to the original design, it would be possible to build a mechanical system, or at least have the mechanical system be actual motor, and it would be highly accurate, and the output would follow the input as shown by the meter. That's why your eye has a control system, so it can be highly accurate with respect to the accommodation system. There is no failure. Evolution designed this type of system, and I will always stand by this analysis as being both very accurate and essential to understand the behavior of all eyes, both plus and minus. I know there's going to be an argument about this, but I derive this analysis from an understanding that evolution designed this a dynamic control system, and all I do is characterize that system by electromechanical design and comparing the results with actual facts and actual science. I'm sorry to say that many people don't do that. I hope you enjoyed this as I enjoyed creating the models. Thank you.